Alright guys, this is the second review sheet on similar figures. The first page here is actually the last page of the other one. So just a quick refresher. Remember when you're finding the equation of a line, after you dilate it, check the center, plug it in. Is it on the line? If it is, you're going to choose the line that matches. So like number 23 here, right? We plug the center in, it works, so we just choose the equation they gave us. Same thing with 25 down here, right? It works, choose the equation they gave us. If you have a line segment and you dilate it, you're just multiplying the length times the scale factor, okay, for this one. For 22, they want to know which could be its image, so we're just looking to see which of these is parallel, and then the same thing down here, okay? For the next page, we did this one already as well, but just remember when you're trying to find the ratio of the sides, if they're giving you diagonal sides, can you use the horizontal ones to come up with the ratio? So, for example, you can see this here, this piece, right, is 4, okay, and then going all the way across from A to D here is 6. So from DE, which is the bigger side, would be 4 over 6. Sorry, bigger side. So 6 over 4, which is 3 over 2. And just be careful because there's 2/3, 3 over 2. We want the bigger one first, okay? In number 2, which of the following would make the two triangles similar by side angle side? If we're looking at the sides they're giving us LM here, right? Which would match with ST, right? LM, ST, you can see from the letters, okay? And then the other one they're giving us is LN, which matches SU. So the angle that's going to make those two congruent is going to be angle L here and angle S. So we can cross off, right? Choice is 2 because it's T and M, and 4. And then all we want to see is which of these is in the same ratio. So is 55 to 30 the same as 33 over 18? Or is it the same as 24 over 12? And you can easily probably tell that this is not going to be equal here, right? This is a 2 to 1, 30, this should be 60. So we're left with this guy right here. With, if you do reduce it down, is going to be 11 over 6. So they are both proportional. We'd want to choose choice 1 here, alright? Number 3, and you can just type in your calculator, cross multiply, do you get the same cross products? That's kind of what we're looking to see here. Or if you hit enter, is it going to be 11 over 6? Okay, triangle ABC is similar to triangle XYZ. Pretty much here on this one, what you're looking to do is just draw yourselves two triangles, right? Draw yourself a triangle and then label it ABC. Doesn't have to look specifically like anything particular. And I'm going to draw one, and actually, this one should actually be smaller because it's 15 and 5. So, smaller guy, X, Y, Z, right? So if this is 15, and then XY is 5, and the perimeter, the area of triangle ABC is 27, what's the area over here? Remember, the mistake to make here, right, the mistake people are going to make is they're going to say, I'm going to do 15 over 5 for that ratio equals 27, right, over, I don't know. And that's wrong, okay? Remember that we can't compare sides to areas. We need to square this. Now, if you want to reduce this down to 3 over 1 first, so it's 3 over 1 squared equals 27 over, I don't know, go ahead. It shouldn't matter. This is 225 over 25 is equal to 27 over x. And you can cross multiply from here. Here we're going to get 27 is equal to, and remember this is going to turn into 9, right? This is 9 to 1. So equals 9x. We divide by 9. Maybe we should get 3. If we're using bigger numbers here, like the totally fine to do, okay? 25 times 27 is 675, so 25x equals 675, alright? And we divide that by Okay, we definitely did that wrong. Let's try that again. Oh, yeah. 675 divided by 225. There we go. And then that's why this is coming off weird. Right? We're going to get x equals 3. Okay, so either way you should get 3 for an answer, and that's the area of triangle ABC. Alright, a triangle is dilated by a scale factor of a half, which following is true. Remember, the scale factor is the same as the area, is the same as the perimeter, okay, or the length of the sides, ratio of the sides. So the area should be that squared, so 1/2 squared is indeed 1/4, so this is true. The measure of each angle should not be, right, they should be equal, not 1/2. The perimeter should be the same, so this should be a half because that's the scale factor, and the length of each side is not equal. It should be half the length of the pre-image, okay? And actually it should be 2 times the length of the pre-image, because the pre-image is going down by a half. So our correct answer we're going to choose here is choice 1. Alright? And number 5, the ratio of similarity of the triangles is 2 to 3. This is just the scale factor of the ratio of the sides. So AB to RS, and it's the same thing, right? We can see the 2 letters here and mentioned here. So AB to RS, so x plus 3, okay, over, or 2x minus 1, should also be in the same ratio of 2 to 3. And that's all we're going to do here is cross multiply and solve. So 3 times x plus 3 should equal 2 times 2x minus 1. This is 3x plus 9 equals 4x minus 2. And then from here, we're just going to get the x's on both sides. So subtract 3x. We get 9 is equal to x minus 2. We'll add the 2, and we'll get x is equal to 11. Be careful because it wants the length of RS, which is 2 times 11 minus 1, right? So that means RS is 22 minus 1, which is 21. So just be careful when you're doing that one. And are the number 6 actually bleeds into the next page here. So it says, is VUM, at least on mine, similar to LMK, and then justify your answer. So we don't have any angles, so we can't use like angle or side angle sides. We just have to compare the sides here. We're going to check for side similarity, okay? So I'm going to make a ratio. Now remember, the easiest way to do the ratio here, okay, is to take the small sides first. So 19 is the smallest over here, 27 is the smallest over here. And then I'm going to compare it to the next sizes. So I can actually choose the biggest over here, which is 28, the biggest over here, which is 42, and then I just have the ones left over, which is 26 and 39. And so what I want to know is, do each of these fractions kind of reduce down to give you the same thing? If they do, then they're similar, and if they don't, then they're not. So if you take a look at, for example, 19 over 27, right? Doesn't reduce down at all. It's just left as 19 over 27. 28 over 42 is 2/3. And 26 over 39 is also 2/3. So we can see that these aren't equal, and even though these are, that means that this is not similar. So are the triangles similar? The answer is no, and we just say not all sides are proportional. Or you can just say don't reduce down to the same scale factor. It's up to you. Alright, and then the same thing here for number 7. XYZ is dilated by a scale factor of 4, which is true for the image. So if it's dilated by a scale factor of 4, that means the sides here are 4 times as big as they are here, right? So number 1 would be true, because I need to multiply this by 4 to make it become its image. If I multiply the image by 4, it's just getting bigger. So this is false. And remember, the angles are always equal to each other, right? Not 4 times as big. So we want choice 1 here. Okay? Number 8, good way to do this is to use some colors for yourself. So like we can color in these 2 sets of sides red. Here's some green for you, some Christmassy colors. And then we'll go black, because it might be a little easier to see in the blue maybe. But there you go. Okay, so CP, which is the black side here, over PD, which is the green, so I need black and green on the other side. Then we have RP, which is black, but then QR, which is red. So you can see like those colors aren't, we're not making the same colors with every ratio, so that's not going to work. CD, which is red, over PD, which is green, so we need red over green. And we got RP, which is black, and so that's just throwing it off, right? PQ is red, that doesn't work. All right, 3. CP, black over PD, green, and then PQ, green this time, but it's supposed to be black over RP, so be careful, because it's black over green, and then green over black, and it's got to be consistent, so that also does not work. And here we got black over red, and then black over red, so we want choice 4, because it has the same color sides in ratios here. Alright, number 9, we have our two triangles. We have the guy down here, RES, which we'll color in red, which has sides of 30, 60, and we don't have the other one. And then we have this triangle up here, okay, which we can do in black here for yourselves. And we have FE, which is 108. Now, the two sides that are corresponding are FE and ES. Okay, see? FE, ES, the last two letters in line there, so that's how we know they also go together. So we can make a ratio here and figure out the scale factor. And it says the perimeter is equal to 160. Remember, the ratio of the sides is equal to the ratio of the perimeter. So we're going to make a ratio of these two sides. We can do 108 over 60, and if you want to reduce it, you are more than welcome to. The reason I might reduce it, or I would reduce it here, is because then my numbers that I'm going to multiply are going to be smaller. So in this instance, it's just 9 over 5. So the ratio size is 9 over 5. We know the perimeter of triangle RES, which is the bottom one, is 160, so we can do like 9 over 5 equals some number over 160. And then we can just cross multiply and solve. So 5x is equal to 14,040. Divide by 5. We're going to get x is equal to 288. And that would be the perimeter of triangle GEF. Okay? And that's it for that one. Number 10, pay attention to number 10. There's going to be one similar to this one, where you're going to have the triangles that are kind of not drawn looking like each other, right? So the orientation is going to be off. So we know that when we've done this question before, that angle H and angle D are equal. We know that RD over here is 4. We have RO, which is 6. We have OH, which is 4. We want to find the length of CD. We'll call that X. And the problem is that we have two triangles over here again. And remember that this angle R is actually being shared between them, right? So we have this really big triangle going on here. Alright? And I got my little teeny tiny triangle. And really, in order to really compare these, what I might want to do is redraw the little guy. Now I want actually D to be over here because D and H are equal. I want R to stay where it is because these are supposed to be corresponding because they're equal, which means O is actually going to move up here. So OR is actually going to be 6, DR is 4, and I don't know OD and actually don't even need it. When I'm comparing these, we're actually going to compare, right, the bottom here to this bottom piece, which is 10, and then this top right side over here to this, which is X plus 4. Now, if you got an answer of 15, what you actually did was call this whole side X. And you need to go ahead and take your answer, which is CR, and take 4 away from it to get CD. So you should have gotten 11, and that's your spoiler alert, right? So the ratio here would be 6 over 4 from this side equals X plus 4 over 10. And then we can cross multiply and get 60 equals 4 times X plus 4. So 60 equals 4X plus 16. We'll take away the 16 from both sides and get left with 44 equals 4X. And then when we divide by 4, that's where the 11 comes from, okay? So that's what's going on when we talk about that one. Alright? And then the last page here, we got a couple word problems, so let's take a look at this. So a flagpole casts a shadow that is 16.6 meters long. We've actually done this question before, right? We have a flagpole here, okay? The shadow of it is on the ground. The shadow is 16.60 meters long from start to finish. All right. Tim stands at a distance of 12.45 meters from the base of the flagpole. So here's Tim, right? And this is 12.45 from Tim to the end. And Tim's shadow meets the ends of the flagpole shadow. So Tim's shadow right here ends where the flagpole is. Tim is 1.65 meters tall. And what happens is the sunlight that comes down that hits is creating these two similar triangles, right? Tim's triangle is right here, and you can kind of see that. So here's Tim's triangle in black. There's Tim, right? And we have the triangle going around it, which I guess we can trace over in red since we already got it. So we know what Tim is here. We can subtract 12.45 and 16.6 to end up with, I believe it's 4.45, right? So this side right here is 4.15 meters, okay? And then I don't know what this is. So then we're just going to use a ratio here. We've got similar triangles with right triangles. They're sharing an angle in the corner. So it's x over the bottom here, which is 16.6, is equal to his height, 1.65, over his length of the shadow, which is 4.15. And then I'll just cross multiply, so 4.15x is equal to, and then I just got 4.15 times, nope, not at all, 1.65 times 16.6 is 27.39. It says nearest tenth, so this number is not going to be nice. So just be aware, 4.15, and x is equal to 6.6. And there's the height of the tree, or the flagpole, sorry. And we want meters, of course, right? Number 12, the two triangles are similar. We have the length of AB, which is the first two letters, the length of DE, and it's 3 to 1. So this is 3 times as big as this, which is also 3 to 1. The angles are definitely not 3 to 1, right? They're a ratio of 1 to 1. The area is that squared, which is 9 to 1. So the perimeters, remember, are equal to the sides, and that's one we want to pick there. All right, Delroy's sailboat has two sails that are similar triangles. The larger sail has sides of, so let's go with sailboat, right? And I guess it doesn't really matter. We'll go 10, 24, and 26. Just putting them down. What's the shortest side? The shortest side of the smaller sail is 6 feet. What's the perimeter of the smaller sail? So the shortest side is going to go here, which is 6. Now, all we need to know is what's the ratio of the sides, and then we can use the ratio of the perimeters to do this. So the perimeter of this is really 10 plus 24 plus 26. So the perimeter is 60 feet here. All right. And then all we want to do is figure out the perimeter of the larger figure. Okay. So the perimeter we'll call here x. And we're going to do the ratio of the sides. So 10 over 6 is equal to the ratio of the perimeters, which is 60 over, I don't know. And then we'll just cross multiply and solve. So this is 360 is equal to 10x. We'll divide out, and we're going to get 36 is equal to x. So the perimeter of the smaller sail is just 36 feet. And we're done. And that's it. Now, if you wanted to, your other option is to use this ratio to figure out, let's call this A and B, right? I can do 10 over 6 is equal to 26 over A, and I can cross multiply and solve that way. I can also do 10 over 6 is equal to 24 over B, and I can cross multiply this way. So you have a couple different options in terms of doing this question. So like this is 156. A is actually going to equal 15.6. Okay. This is 14.4. So if you know that this is 15.6 and 14.4, then you can add all three of these up, and you'll get 36 again. So just another option for you. Number 14, Triangle Rst is similar to Triangle XYZ. Rs and XY are given. If the area is 27, determine and state the area, and the other one in squares. So same thing, ratio of the sides. And we know that Rs, first two letters, and XY, second two letters, there's our ratio. This squared is 9/4. So this is the ratio of the areas. And then we're just going to do 9/4 is equal to, Rst is the top number, the bigger number, so 27 over I don't know. And then we just do the same thing for ourselves. So we do 4 times 27 to start with. So we get 108 is equal to 9x. We can divide out by 9 and come up with an answer of 12. And then we have the area of triangle XYZ, okay, in square inches. And this should be inches squared. So the area of triangle XYZ equals 12 square inches. All right, number 15 is going to be a a quadratic question. So I have triangles, I have the angles here. If you want to draw them out for yourself, feel free. Once again, here's A, B, C. I have, be careful, it says Z, X is where B is, Y is by itself, and then we're going to label. So we have A, which is X squared plus 6X. We have Z, which is 5X plus 20. And then we have X, which is 3X plus 2. Now remember, in similar triangles, these angles are equal. So all I need to do is set A equal to Z. So X squared plus 6X is equal to 5X plus 20. Now it's a quadratic with the X squared. So we want to bring everything over to this side first. So now this is equal to 0. We have X squared plus X minus 20 on the left. And then if you drop your diamond here, A times C on the top, which is negative 20. We have 1 on the bottom, and then we're just going to split it. So I know it's 5 and 4 to give me 20. Could be 10 and 2, but remember that those don't add to 1. It's going to be a negative 4 for this to work. And so then we have our 2 parentheses. We have x plus 5 and x minus 4 are equal to 0. And then we just solve. X plus 5 is equal to 0. X is equal to negative 5. X minus 4 is equal to 0. So x is equal to positive 4. We are then going to reject this answer, right? Because we have a negative measure. Remember, it's not length or angle measures here. If I plug a negative 5 in here, right, this is going to give me negative 5. X is going to give me negative 13. Like, that's no good. And then the measure of angle x is 3 times 4 plus 2. So 3 times 4 is 12 plus 2. Measure of angle x is equal to 14 degrees. And that's it for that one. And that's it for the worksheet. All right, guys. See you tomorrow. Sorry for the delay on this. And look later.